Welcome to another video from Rennie Foresights. None of the following content will be financial advice. Today we're going to look at some research about what optimistic rollup is. An optimistic rollup, in the most simplistic sense, without getting to the specifics of how any singular optimistic rollup works, is purely taking a bunch of data. This is the rollup part. It's trying to compress that data. So it's looking for parts of the data that you could remove by bundling it together. Think of like getting a box of stuff at the store instead of a bunch of individual items. So it takes a bunch of transactions, rolls them all up into one transaction, and pushes them all together. By doing that, you're able to get rid of a lot of information, a lot of extra data. And then at the same time, the optimistic part is saying that we're going to say that it's usually true, except for in the case where somebody disputes it. And that's where we get into how each network has its own way of dealing with this dispute. Optimistic rollups, ZK rollups, these are done because of what's called the trilemma. In cryptocurrency, you can have security, scalability, and decentralization. These are kind of the different sides of the triangle. So why are optimistic rollups different? First, we're going to look at the first network to come out for Arbitrum, and then we're going to look at their new network, Arbitrum Nova. Starting with Arbitrum One, their original network, this is a normal optimistic rollup. What we see here is that we're able to have a separate network of validators do all the computation. Okay, so remember that you have only so many computing resources in your decentralized network. So Ethereum has these validators, and these validators have a certain amount of computation that each one can do, and you need to pay for all that redundant computation. By doing this on Arbitrum, you can actually post the final version of that computation. Once the computation is done and you post it, there is dispute resolution. So the reason that Arbitrum takes 7 days to withdraw from right now, this is likely to be lowered in the future, is because of something called dispute resolution. What dispute resolution is one person submits the block of transactions and another person viewing the network says you put a fraudulent transaction in there. What happens is that goes to the contract on Ethereum. Dispute resolution starts. So basically the contract asks, okay, what part of this transaction are you disputing? Are you disputing this part or that part? The two parties basically go back and forth with the contract and say, I believe it to be this way. And the other person says, no, it's this way. Here's my information for why it's that way. Until they break down to the actual single part that they're disputing. So for example, this could be one specific transaction in which somebody tried to fraudulently put through on one side, and the other person is basically calling them out on it, saying, no, this is not correct. Then Ethereum comes in as the judge and does the math on just that transaction. This is where we reduce a lot of the gas costs because we only are disputing the judge part on Ethereum where this dispute actually happens. When there's no dispute, what we call the optimistic case, the network just goes on and accepts that data. Who can dispute this? Well, technically anyone can dispute this. So all you need is one honest participant. No one else can lie. Let's say there's 100 participants, you could have the other 99 collude together, and the one participant can go to the Ethereum network, point out exactly where the math is wrong, the Ethereum network will check it, and it will actually take the funds that are staked from the one who is being dishonest, give part of it to the one who's being honest, and part of it will get burned. So there's economic incentive to actually call out when there's something fraudulent happening, because you know that this is false, so you know that you are guaranteed to actually get a reward for calling out what is wrong. At the same time, you also are able to have the person who did a fraudulent transaction have an incredibly unlikelihood of getting away with their transaction, and a quite high likelihood that one participant calls them out and they just continuously lose money. Therefore, it's highly in favor of incentivization of honest parties being honest and having all the transaction data correct in the network. One of the arguments that are made about these rollups is data composability. And this is actually a little bit of a problem, but better than what we currently have. So understand that blockchain technology is about taking trust assumptions and siloed data and putting it into public networks that operate in a trustless way, or have a mechanism like this where it's basically secured by something that can remove the trust. So we're taking all this compiled data and posting it as call data on the Ethereum blockchain. So you can actually pull up the data after compression and view the data that happened on the Optimistic network. But you do not need to pay the network for the computation of that data. So you save on the computation costs. What does Arbitrum Nova do that's different? Arbitrum Nova has its own data. So instead of basically bundling and compiling the data to Ethereum, you're running the data between a bunch of validators. These are supposed to be trusted entities. So for example, you have 10 different companies working together. Now, this does have a case where you could have all of them collude and basically the network doesn't work. So there are some risks. But this type of network is supposed to be an improvement on a network where you could actually have 50%, let's say, of the people collude and cause a huge problem of a bunch of companies working together, versus this making it a much smaller number. You could have 2 of 10 or 2 of 20 case where as long as 2 of the 20 people are honest, then you're okay. So what happens? Well, you basically do all the transactions between these parties, but if, for example, 2 of the participants say that these people are being dishonest, meaning these other companies that are running the validators, they can point out those transactions. Through an automated process, the network will fall back into a rollup, exactly like what was explained for Arbitrum One. This is why it's really important that I explain what Arbitrum One does first, because Arbitrum Nova has a fallback mechanism that operates in a much more centralized way, running the data between these parties. It's much different than a traditional system in that it has this fallback mechanism. So it says, in the case that there is some type of dispute and a few parties disagree, then we actually go back to the optimistic case. Then the dispute resolution in an optimistic case could actually take it to the Ethereum network, in which case you'd actually have all the network validators of the Ethereum network be able to check the computation of this dispute that was happening. So you go from the data being here to the data going into an optimistic state to it actually checking with the Ethereum network. Because of this fallback to public network, you have a lot more data security. What is this good for? Well, this application is probably not ideal for the use case that networks like Bitcoin or Ethereum are looking to do, like how to take tons of high value transactions and process them. More usable for, like, what if I want to pass my NFT around a bunch of times with somebody, or do low value transactions like $1 transactions. They become much more possible for those transactions, of which you don't need the same risk assurances because you do not have the same amount of capital at stake as somebody, for example, trying to do $5 million transfer on the Bitcoin network. All right, thank you very much for watching this video. This has been another video from Rennie Forsyths. Have a great day.